Alright, so today we move on to lesson 6.3. Take a look at your problem of the day. The short response says, explain how you can tell that square root of x plus 4 equals negative 5 has no solution without solving it. I want you to pause and write something down from the video. Alright, so lesson 6.3 is called Perform Function Operations in Composition, and we break it up into three parts. So what we start off with is focusing purely on the domain for the first two slides. All right, so let's review. What is a domain? I mean, you learned what a domain was way back in chapter 1, like one of the first lessons. A domain is a set of input values, or x. So any x of your xy coordinate. Way back you learned what domain and range were. Domain of functions, all the values that go into a function. So all the numbers that you can plug in that will give you a real answer. Now, how we apply that to finding the domain for each function, if you look at letter A is f of x equals 2x squared minus x plus 1. Now actually, before we even solve it, if you take a look, I can use any letter. F of x is a common one we use, but I can also use g of x, h of x, p of x. You can use any letter you want. You might be wondering, well, why do we do that? Because we need to designate, later on in the lesson you'll learn, what if I give you more than one function? We have to designate or show the difference between them. So the letter outside really doesn't matter. If you look here, what we have is 2x squared minus x plus 1. I could plug in 0 and get a real number. I could plug in 10 and get a real number. I could plug in negative 1,523 and get a real number. So my domain for A, use D for it, is all real numbers. So once again, all real numbers means any real number that I plug in for X, I'm going to get a real number for Y. All right. Now B is slightly different. Here we have a square root. Can you think back to what numbers cannot go under a square root? Hopefully you remember negative numbers cannot go under a square root. All right. So this one, I can plug in 0 and get a real number. I could plug in 1. Square root of 1 is 1. I could plug in 2. But what if I plugged in negative 4? If I plugged in negative 4 here, I get square root of negative 4, which is 2i. So for this case, my domain is actually going to be a range. It's going to be x greater than or equal to 0. So what I would do, once again, is I'd set x equal to 0. I mean, obviously, just 0. I'm not really solving for anything. I'm setting inside the root equals 0. I could do 0. I could plug in 1. I could plug in 2, so on and so forth. Now, on letter C, what happens when it's a fraction? A fraction, what can the denominator not equal? The denominator cannot equal 0. So let's set it equal to 0. And off to the side, you're going to want to write this down. 2x minus 6 equals 0. 2x will equal 6. Divided by 2, x equals 3. All right. So if I plug in 3, 2 times 3 is 6. 6 minus 6 is 0. The only number that will not work is 3. So my domain is all real numbers except x equals 3. That's how I write it. All real numbers except x equals 3. I could plug any other number in and it's going to work. It's going to give me a real number answer. It could be a decimal or a fraction. That's okay, but it'll be a real number, no imaginary. All right, now if you look in letter D, once again, we're going to look at the denominator. Make sure you can see a little line there. There we go. Oh, maybe I shouldn't do that. And if we take a look here, it's a combination of B and C, right? Because it's an even root, a square root, and it's also a fraction. So what we do, once again, take what's inside the root, set it equal to 0, like we did here. I mean, here it was just 0 because it was just x. Solve algebraically. Make sure you write this down. You get x equals 3. Now, if I plug numbers in, if I plug in 3, right? 3 times 3 is 9, 9 minus 9 is 0. Square root of 0 is 0. Can I have a 0 in the denominator? No. All right. What if I plug in 4? 3 times 4 is 12. 12 minus 9 is 3. Square root of 3 is a real number. So what I'm going to find out for my domain is it's just going to be x greater than 3. So how is that different from b? It's not or equal to, because it's a fraction in the denominator. It's a fraction. All right, so it can't equal 3. If it equals 3, the denominator is going to be 0. So it's a combination B and C. So to recap, in letter A, if it's just a regular function that is not a fraction and not an even or square root, it's just all real numbers. Where you start to have the restrictions on it are like B through D. So let's come up with another set of examples, and I want to talk about the general rules for the domain. Fractions. Denominator cannot equal 0. So we'll set it equal to 0 to show what it cannot be. Square or even roots cannot have a negative number under the root. That will also go for, as you see later on, if it's a fraction in the denominator, like a fractional exponent, the denominator cannot be even. So the same thing will apply. All right, let's see if I can make this one a little bit bigger without losing it. Okay, so let's look at this next one here. F of x equals 2x minus 1 over x plus 2 times x minus 3. We have a fraction. Fraction denominator cannot equal 0. So we're going to take each parenthesis and set it equal to 0. So my domain, there's going to be two numbers that do not work, right? All real numbers except, move this up a little, x equals -2, 3. So all real numbers except x equals -2 or 3. There are two solutions that will give me 0 here. All right, let's look at B. B is just like before, combination of B and C or D here. So use that to help you. We set the denominator equal to 0. 7x minus 5 equals 0. Add 5 to both sides. 7x equals 5. Divide by 7, x equals 5/7. Now, so my domain for this one, whenever it's a root, it is going to be a range of numbers. Now, it can't be equal to because it is in the denominator. So x is going to be greater than 5/7. That's my domain. Just like letter D here. Can't be equal to because it's a fraction. All right, so let's look at C. Set the denominator equal to 0. Now you can solve algebraically, but what I like to do is factor. It's a difference of two squares pattern. So it's that x plus 2, x minus 2. Set them each equal to 0. X equals -2, 2. So my domain is going to be all real numbers except x equals -2 and 2. All right. Now, for the last slide, the last topic we're going to take a look at is actually, it should be easy. We're looking at evaluating functions, and you did this in chapter 1. The only issue that you might have when you evaluate or use substitution property is if you do sign or order of operation errors. So hopefully this should be a review, but let's make sure that you practice it and take your time to not make those errors. Okay, so evaluate the following functions at the given x values. A, f of x equals x squared minus 3x minus 11 for f of -2. That means, and we've done function notation a lot, you're going to see it a lot in this chapter now, the rest of this chapter. Every time you see an x, you plug in a -2. Now be careful when you evaluate. I always put parentheses. Order of operations tells me first to square. Be careful, -2 squared quantity is a +4. You'll see that next. Then I evaluated -3 times -2, which is +6. From here, 4 plus 6 is 10. 10 minus 11 is negative 1. So this is my answer here. And you're going to leave it like that. F of negative 2 equals negative 1. That you're not solving for f, that's just function notation. All right. Now, be careful with absolute values. First, we're going to evaluate plugging 3 in. So make sure you copy this down and take your time. And absolute values does not mean that you immediately change these two negatives to be a positive. First of all, you treat absolute value bars as parentheses, and you want to keep evaluating the parenthesis or absolute value bar until there's one number. Then if you need to, you can make it positive. So I multiply negative 9 minus 5, absolute value plus 2. Negative 9 minus 5 is negative 14. Now, absolute value of negative 14 is a positive 14 plus 2. Once I evaluate the absolute value, I drop the bars. 14 plus 2, f of 3 equals 16. And then that's my final answer. All right. So that's it for the lesson. Homework, I want you to do the problem of the day. We'll go over it in class tomorrow. Now, assignments 7 and 8 is what we'll do tomorrow. I'm having you do 3 problems on each worksheet, and I will check it as homework tomorrow.